All right. Null hypothesis testing gets at answering a very important question. Let's say that we're conducting an experiment. Here's a graph of our results. We have our dependent variable here on the y-axis. We have our independent variable here, and there are two levels of it such that we have a control group and an experimental group. We have some treatment, really doesn't matter what it is for this thought exercise, that creates one difference and one difference only between these two groups. If our dependent variable is on an interval or ratio scale, we would probably calculate a mean value, and we'd calculate some measure of variation as well. And then we do the same for our experimental group. Now, looking at this graph, it looks like the mean of our experimental group is greater than the mean of our control group. Does this mean that our independent variable caused an increase in the dependent variable? Is there a causal relationship here? The answer to that question is, well, maybe, maybe not. We do know that ultimately this is a sample, and this is a sample. And more specifically, these are sample means. And we know that sample means come from a population and that there is sampling error. So, it's possible that they're coming from the same population. Our independent variable is doing nothing, and this difference between these two means comes down to nothing but sampling error. However, if our independent variable truly is doing something, it should cause a difference between these two. And if that difference is big enough, specifically if it's greater than the effect of sampling error, we could reasonably say that, hey, look, our independent variable is doing something. It's causing a change to the dependent variable. So the question that we really need to answer is how big of a difference is big enough? This is the question that null hypothesis testing tries to answer. So, how does it go about doing this? It does this by using a pair of mutually exclusive and exhaustive statistical hypotheses. So, statistical hypotheses are a special breed of hypotheses. Specifically, they are testable assumptions about a population parameter. Now, there are always two. There is always the null hypothesis and the alternative hypothesis. Now, the key thing is these two hypotheses are always mutually exclusive and mutually exhaustive. If they are mutually exclusive, what that means is that if one is true, the other has to be false. And if one is false, the other has to be true. Another way to state that is if the null hypothesis is true, then the alternative hypothesis must be false. And if the alternative hypothesis is true, the null hypothesis has to be false. Now, the other aspect is that they have to be mutually exhaustive. If I can spell exhaustive today. What this means is they have to be the only two options. So, really what we're saying here is these are the only two situations or states that reality can be in, and if one is true, the other must be false, and if one is false, the other must be true. Now, let's dive into what each of these hypotheses are a little bit more. The null hypothesis essentially states that everything is due to random chance. So, this mean difference that we're seeing here, it's just dumb luck. It's just sampling error. It's the luck of the draw that we got two samples that are this different. The alternative hypothesis, however, makes the mutually exclusive and exhaustive assumption. Not everything is due to random chance. So, it's due to random chance, or it's not. If it is completely due to random chance, then this has to be false. And if not everything's due to random chance, this has to be false. Mutually exclusive and exhaustive. Now, the nice thing about the null hypothesis is, if everything's due to random chance, we can use probability to determine what is the likelihood that this null hypothesis is actually true. This allows us to determine and to essentially put that null hypothesis on trial. So, when we think about null hypothesis testing, what we're really doing is we're calculating the probability that the null hypothesis is true, then we are using that probability to make a judgment. It's really a lot like a court case or a criminal trial. We're assuming the null hypothesis is innocent of being false until it is proven guilty beyond a reasonable doubt. So, when you think about this, if the probability that the null hypothesis is true is sufficiently low, then we decide that the null hypothesis is not true, which means the alternative hypothesis has to be true. So again, to sum that up, if the probability that 80 is true is very low, then we reject it. If we reject it, we have to accept the alternative hypothesis. Now, one key element that comes up is how low of a probability is low enough. Now, this is ultimately a subjective decision. However, the common decision rules, or alpha levels, the probability below which one would reject the null hypothesis, that are typically used are 0.05 and 0.01 in the behavioral and biological sciences. Now, 0.5 is far and away the most common, especially if you're talking neuroscience, psychology, and biology. However, there is a push, especially in some areas of psychology, to move it to 0.01. Now, this probability, this decision rule, is called our alpha level. And if we formally state it, it is the probability below which we reject the null hypothesis. So, to sum it all up, we go out, we conduct an experiment, we collect some data, we have these two samples, they are different. We need to know, is this difference between the samples just due to random chance, or is there some systematic factor which is causing them to be different? Which, if we set up our experiment correctly, the only reasonable explanation would be the independent variable. So we calculate the probability that we would get these two samples, and more specifically, the difference between these two samples due to random chance. If that probability is sufficiently low, specifically if it's below whatever alpha level we select, which is typically going to be 0.05. So if there's less than a 5% chance of getting means this different, then we reject the null hypothesis and accept the alternative that not everything is due to random chance and there is something causing these means to be different, which, if we set up our experiment correctly, has to be the independent variable.